Okay, let's discuss this third partial exam. The first one, we evaluate the sine inverse of sine 13 pi over 7. Remember, we have this identity. Sine inverse of sine of x is equal to x only if the x is between negative pi over 2 and the positive pi over 2. Okay, so this is the only case for the simple identity. And we also know that the sine and the sine inverse are both odd function, and the sine function is a periodic function. So I'm going to subtract 2 pi from 13 pi over 7. From 13 pi over 7. Because 2 pi is a period of sine. 13 pi over 7 minus 2 pi is negative pi over 7. Negative pi over 7, right? And this angle is between negative pi over 2 and the positive pi over 2, so it is equal to negative pi over 7. Second problem. We evaluate cotangent of sine inverse of negative 2 over 5. Okay, so first we name the angle sine inverse of negative 2 over 5 by theta. Then the property of theta is that the sine theta is equal to 2 over 5. And the theta is in the quadrant 4. Theta is in quadrant 4 because you have a negative 2 over 5. The sine inverse has a range from in the fourth quadrant and the first quadrant. All right, and remember it's in the quadrant 4. And now in quadrant 4, cosine is what? Cosine is a positive, so cosine theta is equal to square root of 1 minus sine theta squared. In this quadrant, cosine theta is a positive, so we use a fundamental identity to compute cosine theta. 1 minus negative 2 over 5 squared. It's 1 minus 4 over 25. It becomes square root of 21 over 5. All right, so this is cosine. And then the cotangent sine inverse is just cotangent theta. Cotangent theta is cosine of theta over sine of theta. Sine is sine here, sine. Negative 2 over 5. Cosine square root of 21 over 5. So it is equal to negative 2 over square root of 21. So this is the answer. It's correct. If you leave it like this, it's totally correct. If you want, you can also write it as 2 times square root of 2 over square root of 21 over 21. This is also correct. You just rationalize the denominator. Okay? Okay, problem 3. We have arithmetic sequence with x2 is 4, x6 is 14. We're looking for x7 plus x8 plus x12. Okay, so from x2, x6, we know it is x2 is x6. X6 is equal to x2 plus 6 minus 2 times d. D is a common difference. All right, so Here you got 14 is equal to 4 plus, this is a 4d. So we get d is 10 over 4, 5 over 2. D is a 5 over 2. Then we can compute x7 is x6 plus d. So it's a 14 plus 5 over 2. What is it? It's 28, 33 over 2. X12 is x6 plus how many d? 12 minus 6 is 6d. So it's a 3. 3 times 5, 15. 15 plus 14 is 29. So x12 is 29. Okay, now we can compute x7 plus x8 plus x12 is equal to the initial term x7, you cannot change it, and terminal term x12. How many terms? 12 minus 7 and plus 1 over 2. 12 minus 7 is a 5, plus 1 is 6. There's 6 terms. x7 is a 33 over 2. x12 is 29 over 2. Okay, so it becomes a 3 times 33 over 2 plus 29. 29 is a 58 over 2. So it's a 3 times 33 plus 58 is 91 over 2. So it's a 273 over 2. The final answer. This is the final answer. Okay. All right, so problem 4. Problem 4, we verify the identity. So let's see. 1 plus cosine. The left side, we start from the left side. You cannot write equality from the first step. Over sine 2t minus cosine of t. This is the left-hand side. Cosine of 2t is equal to 2 cosine t squared minus 1. This is double angle formula, one of the form. And sine 2t is 2 sine t cosine t minus cosine t. All right? And then you cancel 1 and negative 1. So the numerator becomes 2 cosine t squared. And denominator, you have a common factor, cosine t, cosine t. You factor out cosine t. It's 2 sine t minus 1 with the parentheses. And then you cancel one copy of cosine t. From top and bottom, you get 2 cosine of t over, after you cancel it, it is 2 sine t minus 1, and that's it. That's it. This is left, right hand side, this is left hand side. So you verify it. All right. Problem 5, we solve the equation 5 tangent theta minus 3 is equal to 2. So this equation is simply solved to be tangent theta is equal to 1, right? You move 3 to the right side, that's a 5 over 5, it's a 1. And tangent theta is 1, there's only one solution in one period. So theta is pi over 4, but tangent theta has period pi, fundamental period pi, so it's plus k pi for any integer k. For any integer k. So it's this is the answer. Problem 6. Problem 6, again, it's a verify some equation. Not equation, identity. Verify that the following equation is an identity. Well, let's see. 1 minus cosine x squared over tangent x squared plus 2 sine x squared. This is left-hand side. We always verify from one side to the other side if we don't have any special identity in our mind. Okay, so this one, so first 1 minus cosine theta squared is sine theta squared. Tangent x squared is a sine squared over cosine squared, and plus 2 sine x squared. A quantity over a ratio means this quantity times the reciprocal of the denominator. Right? And then you cancel sine squared, you get cosine squared. Plus 2 sine x squared. 2 sine x squared, let's just write them as a sum, because we are going to use identity. Cosine x squared plus sine x squared is equal to 1. So it's equal to sine of x plus 1. This is a right-hand side. So we do have this equation as an identity. It is an identity. Okay, problem 7. Problem 7, we have find the exact value of tangent to theta. To alpha, given sine alpha equal to negative 3 over 5, and alpha is in quadrant what? Quadrant quadrant 4. In quadrant 4. Okay, well, tangent to alpha is equal to 2 tangent alpha over 1 minus tangent alpha squared. Okay, so this is our formula. Tangent to alpha is equal to 2 tangent alpha over 1 minus tangent alpha squared. So we have sine. If we can find the cosine, we are able to compute the tangent alpha. Okay, so again, in quadrant 4, cosine alpha is positive. In quadrant 4, cosine alpha is positive. So what? So cosine alpha is equal to square root of 1 minus sine alpha squared. So cosine alpha, by the way, cosine alpha is always equal to plus or minus square root of 1 minus sine alpha squared. So here you have to determine the sine based on the quadrant. If you are able to confirm the sine, then you can directly apply the formula. So it's 1 minus, where is it? Negative 3 over 5 squared. So you just compute, it's a 4 over 5. It's not that difficult. It's under the square root is 16 over 25. It's a 4 over 5. Cosine alpha is a 4 over 5. So tangent alpha is negative 3 over 5 over 4 over 5 is negative 3 over 4. This is tangent alpha, negative 3 over 4. It also makes sense. In the quadrant 4, tangent is negative, so it has to be negative. Okay, so once you get the tangent alpha is negative 3 over 4, you compute the tangent to alpha. So it's a 2 times negative 3 over 4 over 1 minus negative 3 over 4 quantity squared. So it's negative 3 over 2 over 1 minus 9 over 16. So it's a negative 3 over 2 times, so here this time it's a 16 minus 9 is 7. 7 over 16. Flip it is 16 over 7. Negative 24 over 7. So it has to be negative. Be careful, it has to be negative. That's it. It's a problem 7. Problem 8. In the right triangle. Right triangle. We know angle C is 90 degrees. Angle B is 35 degrees. Then we know angle A is 180 degrees minus 90 degrees minus 35 degrees is 55 degrees. And C is, the hypotenuse is 3. And this side is B, this side is A. And we know what? We know B opposite over hypotenuse is a sine B, sine 35. So we can quickly get B is equal to 3 sine 35. And then A over 3, it is sine what? Sine 55. So this implies A is 3 sine 55. Of course, you can also write this is equal to cosine 35 degrees because A is adjacent side of angle B. A is the opposite side of angle A. So if you use cosine 35, then A is a 3 cosine 35. By the complementary angle theorem, this is also correct. So the answer, 55, B, and A, or this one. That's it. So we just use the definition of the trigonometric function for the acute angle, in the right triangle. Of course, you can use the law of sine. Then you will have sine 90. Remember, sine 90 is equal to what? Sine 90 degrees is equal to 1. So actually, you have the same thing. Problem 9, we are going to really apply the law of sine. C is 12. Angle C is 12 degrees. Angle A is 20 degrees. This is 20. This is 12 degrees. Then this is angle B. So angle B is 118 minus 20 minus 12 degrees. It's 100 what? It's 148. 148 degrees. And side C is 4. So C over sine C is A over sine A. So side A is C times sine A over sine C. C is 4 sine A. A is 20. Sine B, B is 12. C over sine C is B over sine B, implies B is equal to C sine B over sine C. So it's 4 times sine 148 degrees over sine of 12 degrees. Yeah. So that's it. So we have 1, 2, and 3 parts. Okay, this is the law of sine, the law of sine. Problem 10 is the law of cosine. So you have an angle 20 degrees. One side is 5, A is a 5. Angle B is 20 degrees. The other side C is a 7. So we're looking for B. The law of cosine is B squared is equal to A squared plus C squared minus 2AC cosine B. 2AC cosine B. So B squared is equal to A squared is 25, C squared is 49 minus 2 times 5 times 7 times cosine what? 20 degrees. What is it? It's a 74 minus 70 cosine 20 degrees. And B represents a side. B is always positive, so B is equal to square root of 74 minus 70 cosine 20 degrees. And that's it. Okay. The last one, you just repeat, and then repeat. A sub n is equal to 2 times A sub n minus 1. Be careful, this n minus 1 is the index. It's not a n minus 1 plus 3. With A1 is equal to 2. Okay, A1 is 2. A2, now you're going to use n is 2, then here's a n minus 1 becomes 1, so it's 2 times A1 plus 3. 2 times A1 plus 3. A1 is 2, so 2 times 2 is 4, 4 plus 3 is 7. And A3 is 2 times A2, you see, 3 minus 1 is 2, and plus 3. Okay, so 2 times 7 is 14. 14 plus 3 is 17. And then we have A4. A4 is 2 times A3 plus 3. So 17 times 2 is 34. 34 plus 3, 37. A5. A5 is 2 times A4 plus 3. Okay, 37 times 2 is 74. 74 plus 3 is 77. Okay, and A6 is 2 times A5 plus 3. So 77 times 2 is 154 plus 3 is 157. That's it, 157. We need the term 6, the sixth term, term 6, and we finish. Okay, so that's it. That's the discussion of this third partial exam. If you have any question, you can send me email. Okay, thank you very much. First page. Second page. And page 3. Thank you.